Now we've talked about the positions of stars, which then leads us to the topic of the path of stars. What paths are the stars taking? Okay, so the diurnal motion of the diurnal or diurnal motion of the sky is the daily motion of stars across the celestial sphere due to Earth's rotation around its own axis. This is again similar to why the sun rises every day, sets every day. Rises, sets, rises, sets. Why does it rise and set? Because the Earth rotates around its axis every 24 hours. The stars do the same thing too. Rise, set, rise, set, rise, set, every day. Okay? The stars close to the celestial equator, like the ones I was just mentioning earlier, these ones, they go like this and then they set. They go like this, they're set. Okay? So they rise in the east, they move towards the west. Now, as I start looking more towards the north, rise, set, there's going to be a certain set of stars that are never going to rise and set. They are going to be the stars that are near the north celestial pole. Look at this one here. And this picture is shown to you kind of from the perspective of LA. So you see the trees here? This is the, so if you're in LA, you look towards north, you see trees and stuff. You look 30 degrees up, remember 34 degrees up? That's Polaris. It's at the end of the Little Dipper. This is the Big Dipper. And this sky is going to be going like that, slowly rotating. Okay? There's going to be a certain set of them that are never going to rise and set. They're always going to be visible during the course of the year. And this is called north circumpolar stars. We're going to talk about that topic in a few minutes. These are north circumpolar. So if you get out on an evening in January, February, March, April, June, July, August, any time of the year, you should be able to see majority of Ursa Major. You should be able to see Ursa Minor, Cepheus, Cassiope, Perseus. These will be rotating counterclockwise. Okay? So stars close to the north celestial pole rotate counterclockwise, like that. Stars close to the south celestial pole would rotate what direction? So imagine this whole thing is turning like this, right? This whole thing is going like that. And now I'm looking south. You see? So if you live in the southern hemisphere and you look towards your sky, what direction are they going to be rotating? They're going to rise in the east, they're going to set in the west, and then they're going to be rotating like that, clockwise. You see? But since we're looking at it this way, it's counterclockwise. You see? Okay, so that's the daily motion of the stars. Why do they do that? Because the Earth spins around its axis once every 24 hours. We call that rotation. Now, besides rotating, what does the Earth also do? The Earth also revolves around the sun. That's called revolution. So rotation, revolution. The revolution of the Earth also causes the annual motion of the stars. It's the yearly motion of stars across the celestial sphere due to Earth's revolution around the sun. The annual motion resembles the diurnal motion. Planets also move from east to west, but slower. Therefore, they appear to be moving from west to east. I'll mention this a little bit in a few minutes, but let's focus in on the annual motion and describe what do I mean by that. Okay, so Okay, so take, for example, Ursa Minor. Let's say Ursa Minor, right now it's 10 o'clock, 10 a.m. Let's say it's right there right now. Will you be able to see it if it's right there? Not during the daytime. The sun is too bright. But it is there. You see, it's there. It doesn't go. Where will it be in an hour? (11 a.m.) Where will it be in an hour? 12 p.m. So what is it doing? Rotating around, right? What is this guy doing? 10 a.m., 11 a.m., 12 p.m., 1 p.m., 2 p.m., so on. Okay, so now let's say it's gone all the way around. Where will it be exactly 24 hours later? Let's erase this so you can see. Where will it be exactly 24 hours later? And here's the key to understanding this. Exactly 24 hours later, it'll be 10 a.m. Is it exactly the same place that it was? No. Where will this be after 24 hours? It will go around and it will be like this. Okay, how about one day after that? Where will it be? How about one day after that? Where will this guy be? So what's happening as the days go by? One day after that, one day after that, one day after that, 1 month after that. 1 month after that in the same time. 2 months after that, 3 months after that, 4, 5, 6, 7, 8, 9, 10, 11. 12 months after that, where is it? Back to where it was today at the same time. So what do we mean by annual motion? After it's gone around a full day, is it exactly where it was? No, it's ahead of itself. The next day it's gone around full, it's ahead of itself. Okay? Why is it doing this? Because when the earth is spinning around the earth, is it standing in place? No, when the earth spins around the sun, it's also going around the sun. You see that? Like that. So the earth is spinning, and every day it's going by like that. So every time that the constellations go around, they're ahead of themselves, like that, and then like that. So after a whole year, they come back to where they were. Okay? So now you see. So if we go to the flat map, same thing will happen here. Let's say this is Orion right now. (10 a.m.) Let's say Orion is up right now. 11 a.m. 12 p.m., 1 p.m., 2 p.m., 3 p.m., 4 p.m., so on, so on, so on. Then it comes back. The next day at 10 a.m., where is it? Tomorrow at 10 a.m. See that? One day later, it's over here. Okay? You know what I'm going to do? I'm going to do this in black because then later on, I'm going to put the planets in there. One day later, where is it? Here. 1 month later, where is it? But of course, the RAs are moving with it. I'm not saying the RA angle is changing. The whole thing is moving with it, you see? So 1 month later, it's over there. 2 months later, it's over there. Okay? After 12 months, where is it? Back to where it started today. So you see that? The annual motion is a slower version of the daily motion. Okay, what are planets doing in the meantime? So let's say Mars is here. 10 a.m. Mars is here. Okay? Mars is here. So every day, the Mars is also doing this. It's going, next day it's here. It's going, next day it's there. And then so on. Now, let's say 1 month later, Orion is here and Mars is here. 2 months later, Orion is here and Mars is here. What seems to be happening? So Mars is going around, Mars is ahead of itself. Mars is going around, Mars is ahead of itself. Mars is going around, Mars is ahead of itself. But it's starting to fall behind the constellation, you see? So if it was in constellation of Orion, after a couple months, it's going to be in a different constellation. So which direction is Mars moving in the sky? Every day, throughout the days. From east to west. This is east to west. Okay, now we come to this prayer sentence. Planets move from east to west in the sky, but they move slower than the stars do. You see? So the analogy of this is kind of like two cars. Let's say Mars is a car, and then the constellation is, so Mars is like a Toyota, let's say, and then the constellations is like a Ferrari, you know. So Toyota is falling behind the Ferrari, right? So compared to the Ferrari, what's the Toyota doing? If you're driving in the Ferrari, you look back at the Toyota seems like it's going backwards, right? No, I'm not trying to diss Toyota, but, you know, Ferrari is Ferrari, you know. So compared to Ferrari, the Toyota looks like it's going backwards, right? So what does this mean? The planets, as compared to the stars, appear to be moving from west to east, you see? So even though the planet is going that way and the stars are also going, see, the stars are going this way, compared to the star, the planet is going this way. Several months later, the constellation is going to be here. Mars is going to be here, way behind the star. So if you're constellation looking back at it, so it's going to look like the planets went that way, okay? So if I ask you on the test, which way do planets move with respect to the stars? They move from west to east, this way. They appear to move west to east. Even though they are actually moving this way, they move that way, okay? So if Mars is right now over here, later on over there, but the constellations are going faster, you see? The next day, the Mars is falling behind. So compared to the stars, they appear to be moving this way, west to east. However, there's going to be something you're going to learn in the next lecture called retrograde motion. Every once in a while, this pattern is going to be ruined. The planet is going to move this way, then it's going to go back. So what's going to happen is they're going to appear to move west to east. Every once in a while, they're going to appear to move east to west. That's called retrograde motion. I will explain to you why retrograde motion happens. It's one of the most important phenomena in the history of astronomy and our understanding of the solar system. Okay, so so far we learned the planet does two things, rotates and revolves. Next, the third thing that the planet Earth does is precesses. So this is precession, like that, okay? The Earth's axis presently points toward the star Polaris. That's why it happens to be our North Star, okay? But it will not point towards the star Polaris for all times. However, it rotates counterclockwise across the celestial sphere one complete rotation takes 26,000 years. Do we notice the effects of precession in our lifetime? No, if it takes 26,000 years, we only live 67 years. What big deal is precession to me? So it really doesn't change you and my life, but eventually it changes things. In AD 14,000, Vega will become the North Star. This kind of shows you the concept of precession and why it precesses. If you ever try to spin something, you will notice that, like this is spinning a top. You could also get a coin, flip the coin on the table, and the coin will rotate. After it slows down, what does the coin do? Starts to go like this, you know. That's precession right there, you see. And then, of course, eventually it falls in the table because of the friction force, okay? So this thing is doing the same thing. It's rotating, and it's also precessing. Earth also precesses, like that. As it's precessing, is the angle changing, the 23.5-degree angle? No. If it did, what would that do to our seasons if the angle changed? It would ruin our seasons, okay? We would not have seasons anymore. So the precession is not like this. It's not a windshield wiper, okay? That would ruin it, and probably life would not be possible like that. So it's more like this, you see? So then if we look in the sky, see, here is where the Earth's axis is pointing in now, Polaris. And then over the course of 26,000 years, it will rotate, come back, 26,000 years one more time, 26,000 years one more time. And you can tell here by the time that AD 14,000 comes, it will be almost halfway across the sky. At that time, Vega will become the North Star. In the past, in 3000 BC, it wasn't Polaris that was the North Star. It was the star Tuban. When we used to do, back then, people looked up in the sky and wondered about the sky, and they said, oh, there's a North Star. But their North Star was the star Tuban and not Polaris, you see? So the effect of this, what is it, therefore? What does it mean to our lives? Basically, one thing it means is that through the course of thousands of years, the sky will change. What's the North Star will change. The other thing it will change is, remember I told you the RA and deck angle of stars. I said it will remain the same in our lifetime, but through the course of thousands of years, the positions of the stars will change. That's because of precession. However, the interesting other thing that this will do, in AD 15,000, to me this is the most interesting part of this. In AD 15,000, Earth's axis will have rotated halfway around. Therefore, December 21 will become the beginning of the summer for the northern hemisphere. To me, this is the most interesting part of this. Remember when I talked about, quickly I mentioned about seasons the other time, I said, in June 21, the Earth axis points towards the sun. And I said that's why we have summer beginning then. And then December 21, the Earth's axis faces away from the sun and winter begins for the northern hemisphere. So here's what happens. After the axis of the Earth is spinning, you see, it's very, very slowly. After it's come 13,000 years from now, 13,000 years from now, it will point this way, right? So right now it's 2000 AD, right? Roughly 2000 AD. In the year 15,000 AD, why 15,000? Because that's a duration of 13,000 years, halfway. What will happen? On June 21, the Earth's axis will face opposite. On December 21, Earth's axis will face towards the sun. So what does that mean to us? Summer will begin in December for the northern hemisphere. And of course, the southern hemisphere will always be opposite to us. When we begin summer, they'll begin winter. Okay? So will this happen suddenly? No. What's going to happen is gradually we will notice, like 1,000 years from now, we will notice that summer is beginning in July. And then 1,000 years after that, we will notice summer starting in August. And then a couple thousand years after that, summer will begin in September. And of course, if summer begins in September, winter begins in March. So everything is shifting. So this is a gradual shift. By the time the year AD 15,000 comes, our summer will begin in December, and our winter will begin in January. So Santa Claus will come on a surfboard. Okay? And of course, for the southern hemisphere, Santa Claus will come with the reindeer and stuff. So the reindeer and the snow stories will not make sense anymore to children of that time. We're going to have to change those stories, you see. So I think this is part of the very interesting part of that.